Hello everyone. Today I'm going to introduce you Static Analyzer Factory, or SAF in short. SAF is basically a static analysis framework for C and C++ code. And before we jump into the details of the design of SAF, let's think about two problems or two questions. So the first one is, why do we need static analyzers? And the second one is, why do we need yet another static analyzer framework? So software has bugs and vulnerabilities, and nowadays most of the memory safety or memory corruption related bugs or vulnerabilities are from the C and C++ code, and these static analyzers are the tools that can be used for capturing these memory corruption bugs in these C and C++ code. So that's why we need static analyzers. And another thing is today's analysis frameworks, like the academic grade ones, like SVF, Fasara, and Lotus, they often require C++ skills and maybe some subclass-based abstractions and pinned LLVM build to use. And onboarding new users or new contributors can take several months. And moreover, these frameworks were not designed for the AI coding agents to use. But nowadays we are using AI agents to code more and more, right? So that is a gap here we want to close. And we make three design choices to close a gap. The first one is that we wrote the core analysis engine in Rust, and we have a zero copy Python binding, which means that the analysis could run in native speed, while we can enjoy the convenience and easy to use nature of the Python language. And the second choice here, design choice, is that because the analysis kernel is written in Rust, we can compile it into WebAssembly and host it as like a static website and run it in the browsers. So we can run this as a static website without the need of a backend, which is very portable. And the third design choice is that we try to make the framework as extensible as possible, so we can draft new checkers in a declarative way, and we also provide two coding agent skills that can help developers to use AI coding agents to maintain the code repository and develop new features of SAF. Now let's see a live demo of the browser-based playground. So basically you can copy your own target program here, or you can just use the examples there. And the same goes for the analyzer, which is obviously written in Python. And now let's run the detection. So you can see that the analyzer has successfully captured the user-free bug in the sample exam, and you can also click around to see all the intermediate analysis results. And now let's get back to the presentation. We did a preliminary evaluation of the default checkers of SAF with the Juliet test suite, and we can see that the default checkers of SAF can outperform the default checkers of existing frameworks in 3 out of 4 bug types. And one more thing behind these checkers is that we didn't write the checkers ourselves as humans. We actually used Cloud Code with Opus 4.6 driven by the coding agent skill to develop the checkers, and we can see that the checker can perform well, and that's why we call SAF agent ready or agent friendly. And before I end the demo, I would like to invite you to try the playground in your browser, and you can also find the source code of everything from GitHub. And thank you for watching the demo.